Hi, and welcome to the OpenSAP Kit Health and Safety App Group Overview. This group of apps is concerned with the integrity of the flight software itself and contains two NASA-guided apps, the Checksum App and the Health and Safety App. In this video, I'm going to introduce you to some of their features by stepping through a demo.
First, I'm going to provide a brief introduction to each of the apps, and then I'll provide details of how the apps are configured for the demo. Here's the Health and Safety app, whose primary purpose is to provide services that monitor the health of the flight software system. The App Monitor table defines which app execution counter should be monitored to verify whether an app is executing properly. The Event Monitor table can be configured to monitor for specific events that are generated by other CFS components. The app and event monitors can take the following actions when a monitor trips. They can send an event message, restart an app, reset the processor, or execute a software bus message that is defined in another HS table. The Health and Safety app has some additional features not shown that are described in the HS app video. The Checksum app monitors memory integrity by periodically verifying checksums for table-defined regions. CS has 4 tables that can be configured to define which regions of memory should be checksummed. The EEPROM table defines blocks in non-volatile memory. The memory table defines blocks in RAM. The app code table lists the names of apps whose code segments should be checksummed. And the tables table lists the names of tables that should be checksummed. If a ground operator is going to change a region of memory that is being checksummed, then they should disable checksumming, make the change, and then instruct checksum to compute a new baseline checksum. CS outputs events, status telemetry, and also maintains a dump-only results table for each checksum table. Here are the apps and tables that are involved in the demo. I've tried to strike a balance of being realistic, but not too complex for a short demo. F42 is an OSK app that implements an attitude control algorithm that has been ported from the 42 simulator, and its name is short for Flight Software 42. An attitude control app is critical, so it is typically being monitored by Health and Safety. In the first demo, F42 will be prevented from executing. F42 depends on sensor data and housekeeping requests, so these will be prevented from occurring. Health and Safety's AppMon table has been configured so Health and Safety monitors F42's execution counters. If F42 fails for 8 cycles, then HS will send an event message. In the second demo, F42 will be sent a special command that will cause F42 to send a critical event message. Health and Safety is configured to monitor for these event messages, and in response, it will restart F42. The third demo involves Checksum. Checksum's table of tables has been configured to checksum Health and Safety's AppMon table. The AppMon table will be corrupted using a Memory Manager app poke command, and then we'll see checksum respond with an event message when the checksum fails. We are now in OpenSAT Kit. I have the main window open, and I already have the CFS running with the terminal window down here. In the application groups, I'm going to select Health and Safety, which brings up this screen, and then under Learning Resources, I'm going to run the CSHS demo script. When I click this, it's going to bring up the Cosmos script runner. I'm just going to hide a couple of windows here. Now when I hit Start, it's just going to do some setups and then go to a wait statement. And if you recall, our first demo is going to be the Health and Safety Monitor F42 execution, and it's going to issue an event message when F42 fails to increment. Part of the setup, it brought up this Health and Safety management screen. We're not really going to use it in the demo, but I just want to point it out that you can do things interactively. Here are all the commands. Here are all the dump and displaying of all the Health and Safety tables. And then for this demo, what's more important is the Application Monitor table has been loaded and is enabled, and the Event Monitor table is loaded and enabled. So when I hit Go, we're going to dump Health and Safety's AppMon table and look at the source code. Not dump the table, but just look at the source code. So when Health and Safety is delivered, it just defaults with some entries for the CFE tables. And as you can see, these are no actions, and we're not going to use those. I've added a 5th entry for F42 that says, after 8 cycles of not executing, issue an event message. So that was the setup when I built the CFE, or CFS. So now I'm going to hit Go, and these scheduler table entries are going to stop F42's inputs from occurring. And health and safety is running in the background. So now it just happened. The event message just happened. And we see that app monitor failure, F42, and it just issued an event as the response. So that ends the first demo. I'm going to just hit go, and these commands will restore the scheduler table back to normal. And in the second demo, we're going to issue a command to F42 that's going to issue the critical event, and then it's going to respond by restarting F42. So once again, we're going to look at the source code for the health and safety event monitor table. We can ignore the first entry. It's not used in the demo. This entry 1, F42, says look for event ID 121, which is that special event, and then take action to restart the app. So the table's all set up. I'm going to hit go, and this just sent this control mode with a special mode of 99. And so it's intended that it's just a special control mode of 99 that invokes a special event monitor of 121, a message, I'm sorry. And the action was restart the application. But as you read through these event messages, you might notice that actually health and safety got errors trying to restart the application. And there's actually some limitations in the Linux port of CFS that prevent this from happening. So after this live demo, I'm going to present a summary of some of the shortcomings of the Linux port that impacts CS and health and safety. So now, since the app start didn't rework, I'm just going to issue a CFE executive service command to start the app. And that does work in this environment. So that's the end of demo 2. For demo 3, we're going to use a Checksum app. So I'm going to hit go, and that demo was involving Checksum. That was checksumming all of the health and safety tables. So this is Checksum's tables table, and the one that we're going to be corrupting is the appmon table. So I just wanted to show that that table is been configured. And then when I hit go again, we're going to switch screens here. So I got rid of the health and safety. Now we see Checksum's table. So I'm going to go over to the tables of tables tab. There's a tab for each of Checksum areas. And once again, there's some commands here that we're not going to worry about. But in the telemetry, we see that the table is enabled and that we have no errors. So the first thing I'm going to do is when I hit go, this script is going to find out where the appmon table is in memory and then corrupt it. And it's actually going to corrupt it with 2% signs just over top of the first application name in there. So we did a peek command to get the address of the table. Then we did a poke to actually corrupt it. And then we got a checksum failure. And sometimes this can take a little while because Checksum's going through all its checksumming regions. But we got it fairly quickly. And here's the appmon table, and it does an expected checksum and a calculated checksum. So when I hit go again, we're just going to dump the corrupted table just to show that the name was indeed corrupted as expected. So what that just did was it dumped the table using CFS table dump. And now we're going to bring up the table manager in Cosmos so we can display the table. So we're going to open in the table location, this temp table file. Now we want to look at the health and safety app monitor table because that's the one that was corrupted. So we just dumped the health and safety app monitor table. And as you recall, the first 5 entries were those CFE application names. And we can see that CFE was clobbered with 2% signs for the executive services. And the other ones are still intact. So we're going to close that. And then hit go. So at this point, normally in operations, it depends why something got corrupted. You could actually, if you did a normal table load over a table, that would corrupt the checksum. So in that case, you should have stopped checksum. This may not be the normal operational action, but I'm just going to let checksum compute a new baseline for this table. And that's what this command is going to do once I hit go. So it computed, and we see that event message was output that says the read compute was finished, and the new baseline is equal to what was the corrupted value, or at least the calculated value after we corrupted the table. This concludes the interactive portion of the demo. Next, we're going to take a look at some of the limitations of the Linux port. As you saw in the demo, HS's restart application didn't work. This slide highlights a few additional things to be aware of. It's not intended to be exhaustive, but to make you aware that just because HS and CS are applications, they are still pretty tightly coupled to the platform layer because of the features they provide. For the Checksum app, the EEPROM table doesn't make sense because there isn't any non-volatile memory in OSK. The memory table has challenges because it doesn't support symbols, so you would need to know the absolute addresses at build time. A tool could be developed to build the tables from runtime information, but that doesn't exist at this time. The application table has challenges because you need to resolve the code space location from the application name that's in the table, and this can't be done because the OS module get information is not implemented for POSIX. For the health and safety app, the restart application fails for similar reasons. And finally, the processor resets aren't practical because you simply exit the Linux process. Don't take these OSK limitations as a reason to dismiss the Checksum app if you're working on a flight mission, especially if you don't have some form of hardware memory error detection and correction. This concludes the Health and Safety App Group intro and demo. I hope you found it useful, and additional videos will go into more details on Checksum and Health and Safety. Thanks for tuning in.